Hi, I'm working on making a video here to work through question 1 from the Chapter 1 review questions. Question 1 reads, a 2011 study by Almeida, Hidalgo, and Yamakami examined a large collection of text messages in order to consider how to filter spam messages. Of all the messages examined, 13.4% were identified as spam. We're also told that the word free is contained in 4.75% of all text messages, and 3.57% of all messages contain both the word free and are marked spam. So first of all, I'm going to start with the information that's given, and then we're going to start answering questions A and B. So looking at the information given, of all messages examined, 13.4% were spam. So for a randomly coming in message, the probability of it being spam is 13.4%, so 0.134. We're also told that free is contained in 4.75% of all text messages, so the probability of a message saying free is 0.0475. And then we're told that free is contained in 3.57% of all messages contain both free and are marked as spam. So the probability of free and, which is the intersection, spam, is 0.0357. So that's what we have to start with. And question A, we're going to figure out what is the probability that a message contains the word free given that it's spam. So free given spam. So to find this conditional probability, I'm going to take the probability that a message says free and is spam divided by the probability that a message is spam. And that's just from the definition of conditional probability. So 0.0357 divided by 0.134, which gives us a probability of 0.266. So there's part A. Part B asks us what is the probability that a message is spam given that it contains the word free. So the probability that it's spam given that it has the word free. Again, using the definition of conditional probability, that's the probability of free and spam divided by the probability that it has the word free in it. So that's 0.0357 divided by the probability of free, 0.0475, which gives us 0.7516. So there are the first two parts. Straightforward application of conditional probability. Part C, we're going to use the fact that the word text is contained in 7.01% of all text messages. So we have the probability of text is 0.0701. And text is in 38.55% of all spam messages. So given that something's a spam message, the chance that it includes the word text is 0.3855. So first thing is just to really understand what the conditional probability is that we're being given. Now for part C, I want to figure out what is the probability that a message is spam given that it contains the word text. So this is going to be the probability that spam and contains the word text divided by the probability that it contains the word text. To find the probability that it's spam and contains the word text, I'm going to use this conditional probability that I was given. This is the probability of text given that it's spam times the probability that a message is spam divided by the probability that the message says text. And now substituting in here, probability of text given spam, we're told, is 0.3855. The probability of a message being spam, we were given in the original problem, 0.134. And the probability that a message says text, we're given in this last part, is 0.0701. And this gives us a probability of a message being spam, given that it says text, of 0.7369. So just looking at it right now, we can see that, if we're thinking about spam filters, which is what this question is about, if in fact a message has the word text in it, there's a pretty good chance that it is spam, right? And if a message has the word free in it, there's also a pretty good chance that it's spam. Next part. Of all spam messages, 17% contain both the word free and the word text. For example, congratulations! You are selected to win a free iPad. Text 8675309 to claim your free iPad. Right? And we're also told that of all non-spam messages, 0.06% contain both the word free and the word text. So, coming through, we've got given more information here. So we're given that the probability of a message containing free and text of all spam messages, so given that it's spam, so free and text given that it's spam, is 17%, so 0.17. And we're also told that of non-spam messages, so given that it's not spam, the probability of containing free and text is 0.06%, so that's 0.0006. So the next part asks us, given that a message contains both the word free and the word text, what is the probability that it's spam? Right? So we saw already that it's a good chance that it's spam if it has either of those words in it. What's the chance if it has both words that it's spam? So probability of being spam, given that it includes both free and text. So to find this, we're going to want to find the probability that we have spam and it includes free and it includes text divided by the probability that it includes free and text. So let's start with the top. The probability that a message is spam and includes free and includes text. This we can find by taking the probability that we have free and text given that it's spam times the probability that it's spam. So this again is using the definition of conditional probability and how we use it to find intersections. So here we were given the probability of free and text given spam is 0.17. We were given the probability of something being spam at the very beginning as 0.134. So the probability of a message being spam and including the word free and including the word text is 0.02278. So that's the first part. So now we've got the top part. Now we need the probability that a message is free and contains the word text. So, to find the probability that a word is free and has the word text, we're going to use the law of total probability. This is equal to the probability that we have free and text given that it's spam. I guess I should do this, times the probability of a message is spam, plus the probability that we have free and text given that a message is not spam, times the probability that a message is not spam. We already found this probability, really it's up here for the first piece. So we've got 0.02278 plus the probability that we have free and text given and not spam, we're given here as 0.0006. And the probability that a message is not spam, since the probability of spam is 0.134, the probability that it's not spam is 1 minus 0.134. If we do these calculations, it gives us 0.0233. And so now coming back to answer part D, the probability of something being spam, given that the message includes free and text, is equal to the probability of this intersection, 0.02278, divided by the probability of free and text, 0.0233, and that gives us 0.978. So if we have a message that includes both the word free and the word text in it, there's almost a 98% chance that it's spam. So if we're thinking about a spam filter, that would be a good message to send to the spam folder. Right? And there's one more part of the question. Given that a message contains the word free but does not contain the word text, what is the probability that it is spam? So, again here, it contains free but not text. That's what's given. And I want to know the probability that it's spam. So, sorry, spam given that it's free is in there but not text. I'll rewrite that so it's a little more legible. This is what we're looking for in part E. So to find this, I'm going to need the probability that I have a message that is spam and contains the word free and does not contain the word text. And I'm going to need to divide by the probability that a message has the word free but does not have the word text. So now I need to find these. Let's see. So in order to find the probability of spam intersect free intersect not text, I'm going to use the fact that I know the probability of spam and free, so a message saying being spam and having the word free, and that has to be the sum of the two probabilities of the probability of spam and free and text plus the probability of a message being spam and having the word free and having not the word text in it. I know the probability of a message being spam and having the word free. We were given that at the beginning, is 0.0357. I know the probability of all three happening together. I calculated that in the last part. That's 0.02278. So the probability of spam and free being there and not having text, I can find by subtracting. So the probability of spam message having the word free and not having text in there is 0.0357 minus 0.02278, which gives me 0.01292. So that's the numerator, right? Now we need the denominator, the probability of a message being having the word free in it but not having the word text. Again, I'm going to use the sort of law of total probability. The probability that a message has the word free in it is the probability that it has the word free in it and the word text in it, plus the probability that we have one that has the word free and does not have the word text. Probability of having the word free, we already have found before, is 0.0475. The probability of free and text we also found before, 0.0233. Now I can subtract to find the probability of free being in the message and not having the word text in the message. And then finally, I can come back and use these two pieces to find the probability that I was looking for. So the probability of a message being spam, given that it has the word free in it, but does not have the word text in it, is the probability of spam intersection with free intersection with not text. We found that to be 0.01292 divided by the probability of free intersected with not text, which we just found to be 0.0242, which gives us 0.5339. So that is the solution to question 1 in the review exercises.